So in section 5.3, we're going to talk about proving some trig identities. So I just want to start by just kind of going through 6 kind of tips or requirements. So number 1 is that you must start with one side of the problem and finish on the other. I do not want you to perform the same operation on both sides of the equation. It's not really a valid proof technique if you're kind of like working on both sides. It's usually start with this, end with that. Okay? So really there's like a brick wall in between the two sides. Don't do stuff to both sides. Okay? Number 2, begin with the more complicated expression and work towards the simpler side. Technically speaking, you can start on either side. It doesn't really matter. In practice, it tends to be easier to go from more complicated to less complicated rather than less complicated to more complicated. That tends to be a little bit easier for students. You have to do less like tricky things like, oh, I'm just going to add 0 here. The way I'm going to write 0 is negative. I'm going to subtract sign and add sign. Like they have to do weird things like that on occasion to get from less complicated to more complicated, which is sometimes not real intuitive. In general, it's probably best to start with the more complicated side. 3, if you get stuck, convert everything into sines and cosines. And then really that rule is a decent suggestion for simplifying. It's maybe not usually the fastest way to do things, but typically not a bad idea. 4, combine fractions by getting a common denominator. 5, the identity a plus b times a minus b equals a squared minus b squared is very useful, especially to set up Pythagorean identities. What is that identity a plus b times a minus b equals a squared minus b squared called? Difference of 2 squares, right? You remember that from last year in your algebra course? Should have talked about that one a lot. We used it a lot. Yeah, okay. I appreciate you humoring me with like, I recognize it. Clearly, this is something you think I should know. I will tell you that I recognize it, even if that is not the case. So, that's fair. And then 6, be mindful of your target expression that you're working towards. What is the other side of the equation supposed to look like? Oftentimes, that'll be useful in like trying to make a decision as to what to do. Bella? Yeah, the problem was getting it all on one. Is that a little better?
Yeah, that's a lot better.
Sure. This is the last section, chapter 5. Don't worry, we're nowhere close to be doing a test before the break, so the test won't come till after you get back from Thanksgiving. Yeah. Oh, I might have misspoke or somebody misunderstood me. I don't know. I don't have any intentions of trying to do this before Thanksgiving. Yeah, there's no need to cram it in. Like it'll be just as fine afterwards. And it sounds like everybody else is trying to cram things in, so I'll be the person that kind of takes their time. So I'm not in a rush. You guys are doing fine. I've been pleased with the work you guys have been doing for me, so we don't need to go crazy. If we don't get it all done, then we don't get it all done, and it is what it is, but it'll be okay. So this is just what I've given you, are just some kind of tips and like guidelines or whatever. And now we're just going to do some examples. We're going to do some proof examples. I'm going to ask for your guys' help while doing these. What would you probably want to have out looking at while we do these? Your identity sheet. Yeah. If you lost yours, you can certainly print another one. If you go to the Chapter 5 page, if you look at the materials, the identity sheet is in the course materials, the very first post on Chapter 5. So if you scroll all the way down to the bottom, you should see that. You can print out another one if you need to. You're welcome. I don't have any extras. I would give you one. I had extras, but I've since given them all away to other students that are like, I lost mine, or I didn't get one, or whatever. Actually, I take that back. I have one that I sit at my desk to use because I don't have the letters and numbers memorized. So, like, I need to look at it to be like, oh, we're going to use R7 or whatever. I mean, I know all the identities. I don't have them, like, memorized by the number and letter, though. Yeah. Yeah, but I've been doing this for whatever million years, too. So, I never had to, well, I take that back. I had to memorize some of them, but, like, the R's and Q's and P1, I think, are probably, I had to memorize. Which are not bad, right? Okay. Are we ready to start the first example? So, first things first, which side is the more complicated side? So, the left side is definitely the more complicated one. Why is that? I have two terms on the left-hand side, one term on the right-hand side. Two terms is more complicated than one. I would want to start on the left-hand side. Everybody okay with that? It had nothing to do with the functions involved. That did not come into my play at all. I wanted to look specifically at how many things do I have. Is that everybody okay with that? Okay. So we're going to start on the left-hand side. What do you want to do first? Does anybody see anything obvious to do? Okay, so Gabe says I want to rewrite tangent as sine over cosine. Sounds good to me. What else would you want to do then? You want to write cotangent as cosine over sine. And I'm just going to put an equal sign here, and I'm just going to work vertical because the left or the right-hand side here is just going to stay the same the whole time. Everybody okay with that? So unlike the simplifying where I have like a big, long, horizontal string of equal signs, here I'm going to work vertically. Does that make sense in how I'm organizing my work? Because that I have an equation now on the right-hand side I'm not going to touch. So I'm going to just work vertical. Okay. Notice that what we did here was tip 3, right? If you get stuck, convert everything into sines and cosines. That's basically what we did. Okay? What to do now? Great. What would that common denominator be? Great. Sine x times cosine x. So the first fraction I need to multiply by sine x, and the second fraction I need to multiply by is cosine x. So that's going to give me, oops, I'll write it that order. That's going to give me this. Everybody okay there? I didn't show making the common denominator, but since you guys suggested it, I just wrote it down after I did it. If you need to fill in that blank on your sheet of paper, I fully encourage you doing that. But that's what we did, was you just made the common denominator. Notice that what we did there was guideline 4 also, right? Where it says combine fractions by getting a common denominator. Okay, what now? Joanna. Yep. So sine squared plus cosine squared is 1. That's using P1. Everybody okay there? Now what? Yeah, when you say split it in half, Sam, what do you really mean there?
1 over cosine times 1 over sine.
Yeah, so he means that this fraction I can think of as the product of these two fractions. Everybody agree with that?
And what made you like want to do that?
Well, look at where we're trying to get to.
Oh, I get it. Yeah.
So remember when we said on, I think it was tip 7,
Yeah.
keep in mind where you're trying to get to, because that should, if you didn't know where you're trying to get to, would it be likely that you'd want to do that? Or would think to do that? Maybe not, but if you know what you're trying to get to, it's like, oh yeah, I see it. And then our last step here is obviously to convert those into secant and cosecant respectively. So we're done. Everybody okay with that? So that's a pretty standard level kind of proof. Like nothing super sneaky happened there. We used a couple of identities. We did some algebra. Pretty similar to simplifying, right? What's the only difference? We knew what the answer is supposed to be. So we knew how to, like, we had some goal to work towards. Ready to do the next one? Okay. So the first thing we'll do is we'll look at each side and try to make a decision about which side appears to be more complicated. Which do you guys think? Yeah, I think it's more, I mean, it's basically kind of the same amount of complicated, but sure, the left-hand side seems fine to start with. Ideas on what to do there, then. You guys need a hint? Read tip 5.
But I just didn't know.
So let's do that. Why would I do that? What do I have in the denominator? I have a minus b times a plus b, right? Does everybody see that? Yes? Okay. So, what are we going to get when we FOIL that denominator out? Yeah, we get 1 minus sine squared n. see any ideas now? Changing the bottom to what? Not to sine squared. Oh, cosine squared. Yes. Okay. Sorry. And Raul, that's what you were going to say? Yeah. Good. That's correct. Everybody's okay with that? That's our modified version of P1. Remember we talked about that you can rearrange those Pythagoreans by adding and subtracting things from both sides? And now what can happen? And we're done, right? So you can start on left side or right side. It doesn't really matter, but you're only going to work on one side. That was the very first thing on our list. If we go back and look at the beginning here, the other way to kind of think about this is if I know that this is my goal, that's my end, right? That's what I know it needs to look like. How can I get a sine x plus 1 in the numerator? Well, the only way to get that is to do something like that, right? That'll get me a sine x plus 1, or a 1 plus, a 1 plus sine in the numerator, right? Which I know I have to end up with somehow. I'm going to just put it there. Right? That's another kind of reasonable explanation as to why I would do that as my first step. Is that okay? So again, looking at where you're trying to get to, helpful. All right? Next one. Which side appears to be the side we want to start with? The left side. Hopefully that's not a shocker to anybody. It certainly looks like the more complicated side. What should we do first here on the left-hand side? Yeah, if we FOIL out the top, that's a difference of 2 squares. So what do we get when we distribute that through? Yeah, 1 minus cosine squared. Okay. So Andrew notices that 1 minus cosine squared is something. That's sine squared. Everybody okay there? Then what? And that's just tangent squared, right? Sine squared over cosine squared. And we're done. Worth mentioning here at this point, is there one way to do these? No, just like the simplifying there, you could take multiple different routes and end up at the same spot. It could be more steps, it could be less steps. We're not concerned about finding everything you could do, just doing one that works. Okay? So if you're comparing answers with a friend, they might do something very different than you. You may still both be correct. One of you might be wrong. Both of you might be wrong because you did some like illegal algebra or something along the way. But it's not one way to do these. Just going through some examples today. Yeah. All right. So the next one here. Which side do you want to start on? I would agree. So what do you want to do first to the right-hand side? What did you say? Good. I agree. I love that idea, in fact. Why do I like that idea so much? I observe I have a sine squared in my answer, so I've gotten that part all taken care of already. Everybody okay with what we did there? Okay. So am I ever going to do anything with that sine squared out front now? No, that's basically locked in. The rest of that stuff now has to somehow turn into that cosine to the fifth. Or really, I have a cosine, so I just need a cosine to the fourth from the part in the brackets, right? Everybody okay there? Hi. You're welcome. David, it's for you. All right. So knowing that we're going to have to concentrate our efforts on this part in the brackets, what do you want to do next? Well, you have 1 minus 2 sine squareds. No. No. Well, if you look at that, doesn't that look like a quadratic? Okay. What if I write 1 minus 2x? I should use a different variable. How about 1 minus 2y plus y squared? Does that look like quadratic? Okay. If y is equal to sine squared x, that's exactly what we have in the bracket there. Right? Do you see that now? Maybe it's not obvious at first glance, but after I point it out, it's like, oh. Okay. We can look at that in a moment, but this is by far going to be the easiest. So how is 1 minus 2y plus y squared, how does that factor? Well, 1 minus y times 1 minus y. We don't want to, though. I'm going to guarantee you that when we fill things in now, we're going to... Everybody okay with that? To see the factoring? Okay. So let's... Remember that y is sine squared. So that's what we factored it down to. Everybody okay with the factor? Jackie, do you have a question? So we found the two numbers that multiplied to give me positive 1 and added to negative 2. And then because we wrote the y's second, I wrote it that way. What can we do here? Cosine squared, though, right? So I have cosine squared. Oops, these are supposed to be a's. I wrote x's here. That's confusing. I'm sorry. And then I still have a squared on the outside of that, right? Okay. Now what? Okay, and that gives me... Yep. And then what do we do then? Good. And that gives us cosine to the 5th, and we're done. Yep, never forget about where you're trying to go, because that's your roadmap that should give you some clues as to what to do along the way. All right, so Gabe, you had asked about, is there a different thing we could have done other than factoring? So let's start over at this factoring step and see if we can do something else to get there. I think we can. I'm not positive, but I have an idea of what we could do. You're not going to like it, though. All right, so to avoid having to factor, what I would do is I'm going to take this piece and I'm going to rewrite this. You ready? So I'm going to write it as minus sine squared a and then minus sine squared a. Because sine squared a minus sine squared a is minus 2 sine squared a. This part, what does that turn into? That's going to turn into cosine squared. And this part, I'm going to factor a sine squared off of. And in fact, I'm going to take a negative sine squared off. Okay there? And this piece, again, that's a cosine. And then I think I'm going to have to turn this into 1 minus cosine also. Okay there? I'll distribute that stuff through. This is going to work. It's not the easiest, but it'll do. So when I do that, I have cosine squared a minus cosine to the 4th a. Oops. And then I distribute that negative through. I told you weren't going to like it. No, I would not. I like the way that we did it to begin with. But if you didn't see factoring, you can just, like, you can use P1 a bunch of times, right? You just have to keep, like, being clever about how you broke that thing apart into a bunch of P1s. Yeah. Is anybody writing this side down? Okay. So, Andrew, I'll move over in just a second as soon as Olivia lets me know that she's done. I don't see anyone else writing off the top of my head. I could be wrong, and if you are still writing, I welcome you to do that. Okay. So, Andrew, you wanted to go back to this side? What? Oh, you wanted the nonsense up top. Okay. So, aside from this last one, it seemed like we were doing pretty okay on the on these proofs, right? They weren't so bad. Occasionally, you'll run into some tough ones, but again, like, you know where you're trying to go to. You know that eventually, if you just keep using identities, like we're doing algebra things that are okay to do, that are like allowed algebra steps, you will kind of, things should start moving in a direction that where you can see where things are going. If things continue to get worse and worse and worse, where you're like, I don't see how I'm getting to the answer here, my suggestion would be to backtrack and go back and try something different. More often than not, things usually start looking better as you go and not start getting worse. This thing accepted, which again, like, I would argue that it continued to get better because I kept getting cosines in there. Even though it got longer, I was getting rid of sines the whole way through. So it kept getting better. Just didn't took a long time to get all the way better, right? So what I'd like for you guys to work on for me. So this is the, hold on, just let me finish, okay? So this is the last of the homework assignments for 5-3. The next class period we're going to take another day as a, like a get caught up / work day, okay? Because I think it's really important that while you're doing these kinds of problems, you have the opportunity to like talk to each other and ask questions and come see me and show me what you've done and get some feedback. I think that's really important to developing any kind of intuition to be able to cope with this kind of thing. So I want to have time in class for you guys to do that. So that's going to be the plan for the next class period. We still have about 30 minutes left of class.